Hi guys, in this video, we're going to break down exactly what a server is, specifically an HTTP server. We'll cover what it actually does, why you need it, why it matters, and even how to build one from scratch. If you've already built a few websites, maybe some React projects, and you're suddenly running into terms like backend, server, or API, you might be wondering, what does all that mean? Or maybe you felt lost when someone says connect to the server or set up the backend. And after you do some Googling, you come across words like Node, Express, APIs, ports, middleware, and it all just starts to feel a little bit overwhelming. If any of that sounds familiar, well, in this video, I want to clear some of that up. Once you understand the relationship between servers and HTTP, a lot of the other backend concepts will finally start to make sense. And my hope is that by the end of this video, you'll have all the foundations to know exactly what an HTTP server is. So let's get into it. Okay, so let's take it right back. At its core, a server is a program, it's a piece of software that forms the back end of your application. So when the front end of your website or your application needs to get some data or it needs to submit some data, it sends a request to the server, which processes the request and sends back a response. It's basically a program that runs on a computer like your laptop, maybe someone else's machine halfway across the world, and its sole purpose is to listen. Specifically, it listens for requests. And when it receives one, it figures out how to respond to that request. Kind of like just a kitchen in a restaurant, for example, right? It's ready to make the food, but it only starts making the food once it receives the order to do so. Now, when I say the server is listening, what I mean is it's running on a specific virtual door, also known as a port or a port number, and it's waiting for requests to come in. So yeah, it's kind of like just standing at this virtual door known as a port. So what is a port, right? Well, you can think of a port just like a telephone number extension. The port number is essentially a number that's added to the end of your IP address, something like this. Together, these numbers tell the browser, go to this IP address, my computer, and knock on this door 3000. And now your computer can have many of these ports open at once. Port 3000, for example, you might be familiar with this, is mostly used for, development. You've probably seen it before as, your local host 3000 when you're running a local server. And so there are other ports, right? Other virtual doors. Port 80, for example, is the default for HTTP traffic. And I'll get into what HTTP is in a second. But then you got port 443, which is used for HTTPS traffic, which is basically HTTP traffic, but it's like wrapped in a more secure and encrypted layer. But basically, in a nutshell, ports, they help your computer know which program or service should handle incoming requests. And to take it back to the phone number analogy, it's kind of like a call center with different extensions, right? Each one routes to a different department or service. That's basically what port numbers are. So when you do see something like localhost 3000, now you're talking to your own computer and you're asking it to listen on port 3000, where your development server is waiting to respond. Now, there's one key detail to understand here, and that is that when you use normal websites, you don't usually see the port number because browsers are smart enough now that they just assume the default port numbers. For example, if you have a look at this website, you can see http, example.com, the browser assumes this is port 80. And then you've got HTTPS, the browser there assumes this is port 443. But if you are using any non-standard ports during development, you need to explicitly write, port 3000 or port 8080, etc. And like I said, each port is tied to a specific service or application, just like a phone number is tied to a specific person or business. And of course, some of these port numbers, they are standardized across the internet and they're reserved for certain types of traffic, so they can't just be changed. Anyway, look, back to servers, right? So when you run a server, specifically a Node.js server, and we'll get into Node in just a second, and it's listening on port 3000, it's literally saying, I'm standing at door 3000. If any HTTP messages come through, I'll handle them. This is essentially what your HTTP server is doing. Now, of course, with servers, there's many different types of servers, right? You have, a file server like Dropbox or Google. You have a mail server that sends and serves up data, and obviously a web server that hosts websites and it serves HTML, CSS, images, etc. And an HTTP server, which is what we're talking about, it usually listens on a specific port, like port 80 for incoming requests. And when one comes in, it reads the request and responds based on what it's being asked to do. So just to really drive this point home, in other words, an HTTP server isn't just any server, it's a specific kind of server designed for one job, which is to listen and handle the kinds of messages that the web browser sends to it. Okay, so now that we know what a server is, it raises a new question, right? How the hell do they actually work? And the answer, like we just mentioned before, is HTTP. So what is HTTP? So HTTP stands for Hypertext Transfer Protocol. Sounds kind of fancy, right? But really, Hypertext Transfer Protocol are like rules in a game. Now, don't get mistaken for it. It's not a program language because you can't write logic or you can't like build apps with it, but instead it's like a set of rules, right? Like the official guidelines in a game, for example. And those guidelines, they can define how computers talk to each other on the internet. So every time that your browser loads a web page or it submits a form, fetches some data, it's speaking in HTTP. It's how your device says something like, hey server, I'd like the home page, and then how your server says, okay, here you go. And of course, you've seen this, right? When you put in a website into your URL, that little HTTP or HTTPS, that's your browser saying, let's use HTTP to talk to this server. So what do some of these requests look like, right? So for a very basic example, let's say that you visit HTTPS, /yourwebsite.com/about. So your browser, which is either Chrome, Firefox, Safari, whatever you're using, sends a message to the server, and that message is an HTTP request sent from your device's IP and port. So here's a very simplified version of the request, right? And so you've got GET, right? One of many different types of HTTP requests. So in this case, it's asking the server to go and get something. And then it asks for the specific page you want. So, /about, and the host. So this is the domain that you're trying to reach. And user agent, this is what kind of browser or device is making the request. And then you have accept. And this tells the server what kind of response the client, like your browser, is hoping to receive. It's like this formal request that says, hi, I'm Chrome, the client. Can I please have the about page? And I'd also like it in HTML if possible. And the server then replies with an HTTP response that might look like this. So the 200 here is a status code, one of many codes an HTTP server can respond with. And it's basically saying, I got your request, everything made sense, and here is the thing that you asked for. Here's the HTML that you asked for. And you can see here that it delivers the HTML, which the browser will analyze or parse and present it, right? Or render it on the page. And it does all of this in milliseconds. And so GET is just one request, right? There are many others, and some of the most popular are obviously GET, it retrieves data. Then there's POST. This sends new data like submitting a form. Then there's PUT, which updates existing data. And it's like saying, I want to replace this with a new version. It's like if you had a blog post, for example, and you wanted to update it, you would use a PUT request. And then there's delete. And this is if you want to remove something, if you want to delete something off the page, or if you want to delete something off the database. And so what you're seeing here is really the building blocks of creating a CRUD application, an application that uses HTTP methods to create, read, update, and delete data from a database using HTTP. Now, out of all of these, GET is definitely the one that you'll see most often, especially when you're working with APIs. But wait, API, what's an API? Okay, so API, it stands for Application Program Interface. Now, even though it's not the main focus of this video, API basically is a set of rules. It's an interface. So an API is like an ATM from a bank, right? You use the ATM's interface, the screen and the buttons, to ask for money, check for your balance, or deposit cash. That's because that's all the bank is allowing you to do with their system. They don't want to let you see the bank's, internal systems, how much money this ATM released today. They don't want you access to other people's accounts. They give you an interface that you can interact with so that they control what you do with their system. So an API, just like an ATM, it kind of acts like a middleman between you and the bank's internal system. So on the web, an API is the middleman between your website and someone else's server or someone else's backend. So let's say you want to share some information on your database. Instead of exposing your entire server to the world, you create an API. So for example, if you're a business that collects weather data and you want others to access that data, but not anything else on your database or anything else that your server handles, you build an API that gives them access only to the weather info. So the API, it becomes this kind of controlled window into your server, into your backend, showing people only what you've allowed, nothing more. And obviously vice versa. If you want to get data from someone else's website, you would access it through their API. So APIs, they act as this kind of security guard on the internet. People build them because they want to share information, but they also want to be clear with the boundaries of what kind of information they want to share. And APIs heavily rely on HTTP methods to do their job. So GET, POST, PUT, delete, it all runs on top of HTTP. So anyway, that's kind of the basics of what HTTP looks like on the internet. It's this structured way for browsers and servers to talk. It's just a smart way for computers talking to each other saying, here's what I need and here is your answer.
Hey guys, I'm just out on my daily run. I thought I would just say that if you've been struggling to stay consistent with learning to code, I created something that I think might be helpful. It's called the Dedicated Dev. It's basically my routine, what I've been following ever since I started coding, and I've put it all in a PDF document. I think it could be really handy for you if you've been struggling to learn to code. There's information on what your sort of daily routine should look like, on what you should be focusing on, how to get focused. Check it out, it's in the description. Now we'll get back to the video.
Okay, so we've already gone through a fair bit, but by now you're probably thinking, okay, hopefully I get what a server is. I know why I need one. I understand what it does. I get what HTTP is, but how do I actually build one of these things? Well, my friend, to do that, I need to introduce you to something called Node.js. So Node.js is what's known as a runtime. It's a program that can interpret and execute JavaScript code outside of the browser. So the browser, like your Chrome, Safari, whatever, it is a program. It allows JavaScript to manipulate, the buttons on the page, animation, drop downs, whatever, the front end stuff that you've been building up until this point. So every browser has what's known as a JavaScript engine, which is basically another program built into the browser that reads JavaScript code and translates it into machine code, sort of this low-level language that your computer actually understands and runs, like binary, ones and zeros. So JavaScript is obviously a more human-friendly code, and the machine isn't smart enough to run it directly. That's why it needs a translator, and that's exactly what this engine does. And specifically for Chrome, their engine is called V8. Now, getting back to Node, before Node.js, there was no other way of reading and running JavaScript outside of the browser. I think there was something else, but it wasn't very popular, Rhino or something. This was a problem because developers were using JavaScript to build websites, and it meant you had to use a completely different language like Ruby, PHP or Java for your backend. Of course, many developers may still argue that this is the better way to do it because some of these languages are a little bit more stable than JavaScript, but I'm not here to get into that debate. I'm here to just talk about Node.js. So let's just move on. So essentially what Node.js did was it allowed developers to just use one language, JavaScript, for both the front end and the back end. With Node, it now provides everything that JavaScript needs to run outside of the browser, just like Chrome's V8 engine, but not in the browser. So the creator of Node took Chrome's V8 engine and built additional tools and features around it so it can do that. And now with Node, you can do things with JavaScript like read and write files, you can interact with databases, you can handle HTTP requests, you can build entire APIs, and you can create your own backend server all with JavaScript, which is exactly what we're about to do. Okay, so hopefully that's all starting to make sense now that you know what Node.js is. Let's build a basic server to tie this whole video together. So we're going to do this twice, right? We're going to be using raw Node.js, and after that, we're going to be using a tool called Express.js so you can see the difference for yourself. And I'll explain what Express.js is as well. So let's start with Node. So building a raw HTTP server in Node. So you can think of Node.js like this, right? Someone took a bunch of backend specific JavaScript tools and functionality. They bundled them all together into this free package for you to build your backend servers, your backend of your website with. When you download Node, you get access to built-in modules, which are basically pre-written modules and functions that you can use. So instead of writing all of that code yourself, you just import the module and you call it what you need. So Node obviously gives you things that you don't normally get in the browser. Things like, access to file systems, network communications, and of course, the ability to build servers. So obviously to start building a server with Node, you have to download it. Plenty of other videos out there to have a look at if you want to download Node. So go ahead and research that for yourself. So once you've downloaded Node, you're going to create a server.js file. And this is the basics of what the code is going to look like. So let's go through this line by line. So require HTTP. This loads modules, built-in HTTP modules. So we can use functions like create server, listen, response end, response write head, and build a working server from scratch. So http.create server. So this creates the server and tells it what to do with it when you get a request. Response head write. This sets the HTTP status code and the response headers. So the status code like 200, for example, that we've spoken about, tells the browser how the request went. So 200 OK means got your request, everything checks out, here's what you asked for. And here's a bunch of other status codes that your browser can send. And so response end, this sends the response body and closes the connection. And then server.listen 3000, this basically opens the door, right? Opens that virtual door. And we're saying start listening on port 3000. It's pretty cool, right? How you can spin up a basic server very easily with Node.js. But there is a catch, right? If you want to handle different pages like about or contact or a whole bunch of other new pages, you'll have to manually inspect request.url and write a bunch of if statements. And you can imagine if you've got a lot of pages, this can get quite bloated and quite messy very, very fast. That is where Express.js comes in. So Express is really a web framework that's built with Node, on top of Node. It takes care of a lot of the messy stuff for you, like routing, like middleware, like headers, so you can focus on building your applications. With routing, this is how your server knows what to do when someone visits a specific page, like the about or the dashboard, or like the about/team page, you know, if there's sub pages. With Node, you have to manually check or request each URL, but with Express, you just tell it what to do. It's very clean and simple, and you'll see what I mean in just a second. And so middleware, you know, what's middleware? Middleware, these are functions that run before your final response. So for example, before someone can access the dashboard, you want to check if they're logged in. That login check, that is middleware. It sits between the request and the response, like it's logic that sits between those two. And you can modify, you know, reject or allow that response to happen based on the parameters that you've set. And then obviously with error handling with Express, you can easily catch errors and show helpful messages instead of crashing your entire app. So you can think of Node as kind of the raw ingredients and Express as kind of the prepared recipe. It's got the same power, but it's just way smoother. So now let's quickly build a server with Express so you can see the difference. Step one is obviously to install Express, and you can do that through npm install Express. Now let's start writing the server. So let's compare that original Node server with Express. With Node, you have to use the create server application, and you've got to write your headers. You've got to, you know, response write head and finish with response end. With Express, all of that gets cleaned up. So here's what each part does. Express sets up your app, right? You're creating the Express server, app.get. This tells the server what to do when someone visits your root URL. You don't need to inspect a request URL. Express just handles all of that for you now. And now response send, this sends a response. So there's no need to write headers or close the connection. App.listen, this starts the server just like Node, but it's a lot more cleaner. It's a lot more elegant. So cleaner, faster, more readable. Now you can probably go on for hours and hours about the difference between Node and Express, but I think you get the general idea, right? Express just makes writing servers easier and far less bloated with code. So that's it, right? That's the general overview of an HTTP server, of HTTP, of Node, of Express. So a server, an HTTP server, is just simply a program that listens for requests and it responds. HTTP is the protocol, sort of the language that browsers and servers use to talk to each other. Node.js, this gives you the power to build those servers using JavaScript, and Express.js just makes that process a lot faster, a lot cleaner, and a lot easier to scale. Thanks so much for watching, guys. Hopefully you got some value from it. If you did, please, you know, leave me a comment. Let me know what you liked, what you didn't like, you know, like the video as well. Make sure that you subscribe to the channel. Hopefully you really enjoyed this one. Thank you so much, and I will see you in the next one.